Here we have another problem that uses Bayes' theorem. Bayes' theorem calculates these conditional probabilities, so the probability of A given that B is true. And to do that, you need the probability of B given that A is true, and you need the probabilities of A and B, and then you just plug them in to this formula here and calculate it. So let's read this problem and see if we can figure out what we want to find and how to find these pieces that go into it. It says the following is a distribution of the causes of fires in homes nationally. So in the whole country, the percent of fires in homes, 33, 15, 17, 6, 10, 19. So 33% of fires in homes are caused by cooking. So when it says 33 here, that's a percent. It means 33 out of 100. And we'll use these fractions for our probabilities because I noticed the answers are in fractions. And then it says, if it is known that a fire is not caused by heating or electrical, what's the probability that is caused by cooking? So we want to find the probability that a fire is caused by cooking, given that you already know it's not from heating or electrical. Okay, so that's our conditional probability, the probability that a fire is caused by cooking if it's not caused by heating or electrical. So we're going to need the probability of A here, which is that a fire is caused by cooking. Well, that's pretty easy. That's just this 33 out of 100. The percent is right there in the chart. So let me jot that down. We're also going to need the probability of B. Now, that's not quite the same. It's the probability that a fire is not caused by heating or electrical. And we have our heating and our electrical system percentages right there. All the rest of these would be the ones that are not caused by heating and electrical. So we could take this 16% and subtract it from 100. You'd get 84%. And I'll write that as 84 out of 100. Okay. Now, the tricky bit here is the other condition we need of B. It's going to seem a little bit strange, maybe. We want the probability that a fire is not caused by heating or electrical if it is caused by cooking. And at first blush, maybe that sentence doesn't make a lot of sense. Is there a probability that the fire is not caused by heating electrical if you know it's caused by cooking? Well, yeah. If a fire is caused by cooking, you absolutely know for sure that it's not caused by something else. It's not caused by heating or electrical system. So the probability that it's not the heating or electrical is actually going to be 100 out of 100 times. You're going to get the fire not caused by heating or electrical if you know it's already caused by cooking. So that's maybe the only tricky bit of this problem here. Now we've got all our pieces. Let's put them together in the formula. So we're going to have the probability of B given A, that's 1, times the probability of A, that's 33 out of 100, all over the probability of B, which is 84 out of 100. And if we simplify a little bit here, so this 1 basically just goes away, multiply anything by 1, it becomes the same. And then if we multiply the big fraction by 100 over 100, you can cancel out these denominators that are the same here. And you're going to get 33 out of 84. And let's see. Yeah, you can divide both of those by 3. So that's going to be 11 out of 28. And I think that's as simple as you can get it. And oh, yeah, here it is, B. So our probability is 11 out of 28 that a fire is caused by cooking if it's not caused by heat or electric. So that's a little bit more work with Bayes' theorem.